QuickNode Functions are serverless functions for blockchain-based applications. Using QuickNode Functions, you can basically deploy your blockchain applications on cloud so that you don't have to take care of infrastructure on your own. You can just deploy your applications or even create APIs in different code bases or runtime environments. Your function is basically deployed on the same server or edge where the QuickNode nodes are there so that you get fast or instant access to the blockchain data. To create a function, you first have to log into your QuickNode dashboard, navigate to the Functions tab, and then click on Create Functions button. And after that, you'll have to either create a new namespace or select one if you already have one. Then give your function a name. Then select the runtime environment. Right now, Node.js and Python are available, but in future, Go, PHP, Ruby, Java, .NET will be available as well. Let us know in the comment section what's the next runtime you'd like us to add. And then give some description that what your function's gonna do. Or you can just keep it anything, whatever you like. So let's name it, this is for the demo. And then you can select a timeout limit where it can be between 5 to 60 seconds. Then concurrency limit, right now it can only be 1, but it might change in future. And then you can set a memory limit for your function, which will be allocated for your function. So it can be anything between 128 to 512 MB or megabytes. Then click on Create Function, and then you will see a functions code editor along with few options for your dataset, where you can select the chain, you can select networks, and then you can select the type of dataset you wish to get. For example, you can get block, you can get block with receipts, you can get just receipt, transactions, logs, trace, block with receipts and debug, block with receipts and trace, etc. And then there's a field for user data where you can provide a JSON object with your variables, where those variables can be user data. For example, in a function, you can use this keyword user_data to get any information from a user. For example, if I write user_data dot wallet_address, I basically can get wallet_address from user. You can provide something like this in a JSON object. So for wallet address, we have provided wallet address, and this will be the value. So this is obviously just limited for this particular runtime, and whenever you want to call your function, you'll have to call your function with this particular value, or you can get this value from a user and call your function. And then you can save and test your function. So over here, what our function should return is a message with parameters, whatever we selected earlier, and the parameters being the chain, network, the dataset which we selected, which is block, and the user data which we sent with the function request. So let's see what we have got. So as you can see, this is the message, and these are the parameters which we requested the function with, and this is the data. And if we scroll all the way down, we will get metadata like the dataset, which is block, the network, which is Ethereum mainnet, and the batch end range and the batch start range, which is a single block in this case, and the user data with which we sent the function. Now save and close the function. And once you save your function, you'll get an endpoint using which you can call your function anytime, along with a API key which you get over here. You'll have to generate an API key if you're creating a function for the first time. And then you can also see metrics related to your function, that how many times it have been called, and then history of your function, and then some logs related to your function. You can also edit your function from here, where you can basically make some changes to your already deployed function. So to make your journey easier in the process of building functions, what we have done is we have created a functions library so that you can explore different kinds of function and get started with building on functions quicker. Just go to quicknode.com/docs and then navigate to the functions section, then functions library section. And over there, you'll find a bunch of functions you can get started with easily. But let's take an example of this one, where you can estimate gas price for a block by averaging few number of transactions. Where over here, as you can see, we are taking the transaction from the user using this variable called number of tx. So if we copy this, go back to our functions, and then select all, paste that example over here, and then we will need this variable to be sent as a user data. So let's do that. What we are basically doing over here is we are saying that let's average 100 transactions to get the average gas price. So let's test the function. We should get average gas price in way and also GUE, and along with a block number. As you can see, we are returning the average gas price in way, average gas price in GUE, and block number. In QuickNode function, for your runtimes in Node.js runtime environment, you can use the following Node.js modules, which are like Node.js core modules, and in Python you can use these Python core modules. But if you were to use a third-party library like Ethers.js, Web3.js, you would also be able to do that. You'll have to just upload a zip file of your code base. So for example, if we go back to our functions library, and if we navigate to a function where we are using a third-party library like Ethers, for example, over here, we are getting USDC balance for a particular wallet address on different chains. So in this case, we also have an environment variable file, and we'll also have some package.json file. So the files look like this. We have node modules, we have package.json, we have package.log.json, we have environment variable file, we have our index.js file, which is the main file. So in such case, what you'll have to do is you'll have to basically select all the files, then compress them. And once they are all compressed, you'll get a .zip file which will contain all the files. So the one thing you'll have to keep in mind is that you do not compress the entire directory of your code base, but you select all the files and then you compress them. So going back to our functions, you would have to upload this file. You can drag and drop it or select from your file system. And since in this code as well, we are getting the wallet address from the user, so that we can get balances from multiple wallet addresses or different wallet addresses, not a hard-coded wallet address. So going back to our function, we will have to replace this with a wallet address variable. We will again use the same wallet address we used earlier. Let's save and test this. So once the function is executed, we'll get the result. So this is what we were returning in our code as well. We are basically returning the balance for different blockchains, and we are also returning an error message or a warning message if the RPC URL is not set in the environment file. So basically, this is how you can use functions library. Let me know in the comment section what more kind of functions you would like to use, or if you'd like to contribute to this functions library. Thank you, everyone.